Are you ready for some chemistry?
That's so funny.
Because I am. It's Monaco, folks.
Wow, that was hilarious.
Atomic theory, structure, and notation. Some brotation here. Very important stuff. Yep. Structure of the atom and my favorite subatomic particles.
I would start by listing these A, B, C, D, E. They're in the picture. We're going to tell you what they is.
I have 3 favorite subatomic particles.
We do. 3, by the way. And before we start telling you what they are, of course, we're going to have our
learning targets.
Yeah. Whoa. So there's 2 of them for the whole video. Recite the names, locations, and properties of Monaco's 3 favorites. Okay. And then find the number of protons. Find the numbers of each of them for an atom or an ion.
Yeah.
Okay. First one.
Protons. Inside the nucleus, mass of 1 atomic mass unit and a positive nuclear charge.
Big key. Positive charge.
Protons, positive.
Yep. And that's what the letter A is pointing to. Mm-hmm. B is referring to the neutrons, which are, of course, also in the nucleus, have a mass of 1, but no charge. They're not as important as protons. Remember, protons are king.
Mm-hmm.
Yeah.
Got the nucleus. That's where the protons and the neutrons are, right in the center. Dense, positively charged. And those protons and neutrons... What's wrong with me? Woo. Protons and neutrons are called nucleons.
Bingo.
Good one.
D is the orbitals. In this particular picture, it's a Bohr model, so it shows like their planets. This is where the electrons live, okay? There's many different levels of orbitals, and so that's why we see lots of rings outside the nucleus. That's where the electrons reside.
Beautiful.
Home base.
And then there's the actual electrons themselves.
Mm-hmm.
They have virtually no mass. I'm not even going to say that number. It's so little, we'd say they have no mass, but they do have charge.
Yes.
So, just in recap, remember, protons have both mass and charge. Neutrons have only mass. Electrons have only charge. So that's why protons be it a key.
Yeah. For shizzy. Now, here's a basic breakdown of my 3 favorite subatomic particles.
We're not going to let them do all 3.
The protons. It's 1 AMU, positive 1 charge. You always find them in the nucleus. There's 2 symbols, either the P or 1P1. 1 on top being the mass, 1 on bottom being the nuclear charge, the P. So you got to look at the atomic number to find out the number of protons. The atomic number is the number of protons.
Right, and so that's a piece where you're going to be able to see on the reference table, atomic number arrow shows you where the atomic number is. It just doesn't tell you on the reference table that the atomic number is the number of protons.
Which is why you got to memorize it.
Yeah. Then we have the neutrons, 0 charge, but they do have mass of 1 AMU. That's an atomic mass unit.
Uh-huh.
And they reside, of course, in the nucleus. We can use an N instead of a P. And we would put a 1 for the overall mass, but the no nuclear charge, so it's a 0. Either of those 2 symbols is good. And the calculation is now we have to do a little bit of math. So the mass number up top minus the atomic number, which is the protons underneath. Mass is protons plus neutrons, right? We learned earlier. So we subtract out the protons, and we've got our number of neutrons.
Mm-hmm.
Got the electron next. Charge of -1. It's got such little mass that we don't even worry about it. We'll call that 0 AMU. It is not in the nucleus. It's outside in those orbitals. You can call it an E or an E with a minus.
Yeah, I use the E with the minus.
Yeah. And it's going to be the same as the protons for a neutral atom. For the ionic charge, you're going to do protons minus electrons.
Yep.
And the overall charge would be 0 for that neutral atom.
Yeah.
Good.
Nucleons is fancy term for the particles that are in the nucleus, aka protons and neutrons. These are also the only ones that have any mass that we really care about.
Right.
So you add the protons, neutrons to get your atomic mass.
And neutral atoms means they have a net charge of 0. Therefore, the number of protons equals the number of electrons.
Mm-hmm.
The number of pluses cancels out the number of negatives.
If it's saying specifically in a neutral atom.
Correct. Well, if they just call it an atom, that's inferring
right.
that it's a neutral atom. So let's make sure we're clear on that.
True.
Okay.
So let's interpret some of the element titles off the periodic table. The atomic mass is always on top. You heard Milk say the top number minus the bottom number. Atomic mass is an average of all the isotopes of an element. So while a single atom will only have a whole number in integer for its atomic mass. This value is taking into account all of the isotopes of an element that are available on our planet as well.
Yep.
That's why it's a decimal.
Yep. And a whole different video will teach you how to do it. The atomic number is the number of protons every element has. Every carbon atom has 6. Or I could go the other way. If I have 6 protons, I have to be carbon. There's no choice. 7 is nitrogen, 8 is oxygen. We'll get familiar with these as we use them more.
This is the electron configuration. So we know that there are 6 electrons because there are 6 protons in the neutral atom, but we want to know where those 6 are. So that's what that number says, that there are 2 in the first level, 4 in the next one.
Right. That is not 2 minus 4 electrons.
You?
Okay, good.
Somebody's going to make that mistake.
It happens every time.
Not me. The element symbol is pretty sweet because that's what everybody already knows about chemistry. It's the single or 2-letter code that identifies us elements. If it's a 2-letter, the first letter has to be capital, the second one has to be lowercase. So
Yes.
you're going to see these all over the place. That's what everybody already knows about chemistry. Yeah, element symbol. Easiest part.
Easiest part. And then this list on the top right, I'm going to let you guys know what it is right now, and then we're going to ignore it for a unit or two.
Mm-hmm.
Right? These are just the possible charges this element can have based on it gaining or losing those electrons that you see in that electron configuration.
They have preferences, is
They
what
do.
it comes down
The
to.
top one is always the preference, but what I don't want you to do is get in the habit of writing them in, because if we're talking about a neutral atom, it doesn't have a charge.
It would have a 0. Every single one of these elements on the periodic table should have a 0 up there as an option.
That's
as well.
what they actually want to be, is 0.
But
neutral.
anyways,
Right.
these are the listed options that it can do.
And this is just going to really summarize everything we
These
just
are
said on this
almost
one.
like definitions that you got to know.
Straight
So,
up.
Yinar, I think you're up.
Sure. Got the average atomic mass. That is the average mass of all of the naturally occurring isotopes of the element. So for carbon, we've got some 12, some 13.
Mm-hmm.
Is that
And
all of
14
them?
too. Carbon 12, 13, and 14.
Yeah,
Yeah.
14 is the one we know the most because it's radioactive.
And they're not present in the same abundance. But we're going to hit that up in another video later. The atomic number is the number of protons in every atom of the element. It is also equal to the nuclear charge, and the protons and the atomic number. They're the same dang thing, but we have to have 3 different terms for them.
Yeah, we do, because we do that.
Mm-hmm.
Electron configuration tells me the number of electron in each energy level. Add the numbers up to get the total number of electrons, of course. It'll also, the number of numbers that are there tell you how many energy levels.
And which period it belongs in the periodic table.
Yep.
Anyways, I get ahead of myself. The selected oxidation states are just the options that the atom has for losing or gaining electrons. It could gain 1 or 2 or 3 or 4, or maybe it loses 1 or 2 or 3 or 4. We list those in the top right corner for selective oxidation states.
Got the symbol, that's the letter that identifies the element. The first letter is going to be capital. It's only going to be 1 capital for each element. The second letter, if there is one, is going to be lowercase.
Always.
And so what we didn't say here is if there's 2 capital letters, that tells us there's got to be now 2 atoms present.
Let me show you what we mean.
Can we do CO?
Yep.
Go C.
CO is not equal to CO.
Right.
That's carbon,
Yep. O is oxygen.
oxygen,
We will learn to name this later and call that carbon monoxide,
but
which you've
that
heard of. That is cobalt. So the case of the letter, right? Capital, lowercase, tells us information, and we need to be able to read and recognize that information so we can be very accurate. This is when Monica and I are going to start telling you attention to detail is very, very important.
We got anything else over here? Oh,
yeah,
my
a little bit.
goodness.
There's a few different ways.
Mad easy.
Right. So this is the nuclear symbol. The nuclear symbol is this because there's 6 protons. Carbon must have 6 neutrons to get a total mass of 12. So this gives me the symbol with both its mass and its atomic number. All of that stuff is in the nucleus. So there we still
Most
call it the
info.
nuclear symbol.
That's me. All right, simplified notation. You're going to get the element name and the mass number.
And
Condensed, mad basic, but it gives you the symbol and mass. And if you have the symbol and mass in the periodic table, you can work backwards to figure out all the other stuff. Anyway.
you're going to see this one a lot. So make sure you familiarize yourself.
A click. button and I made the video turn on.